Alright, well, we got some of these Ryobi batteries. Now these, if the voltage gets low enough, they go open circuit, which is a little bit unusual. I have, for example, this guy, and the batteries for this, these don't go open circuit. So both of these batteries I got, they were really low. This is just a laptop power supply, and I just put on some blade connectors, and the purpose of the light bulb is just because you know, if the battery's really dead, it's too thirsty, it sucks current too fast, and it hits the current limit of the laptop power supply. My zoom is fucked. See how the zoom is all jerky? In is fine, but out, anyway, yeah, you'll hit the current limit of the laptop power supply and it'll go open circuit, and then you got to unplug it, plug it in to reset it. Well, anyway, to prevent that, the light bulb is just a slight resistance in series. So when you hook this thing up, if the batteries are really dead, that filament glows slightly. It's a high wattage resistor. You know, if you put a regular resistor on there, it would get so hot, it would probably melt or damage the resistor. Hence why I use a light bulb and not actually a resistor. Yeah, you could use like a ballast resistor for a truck or something, but the light bulbs are cheaper and easier to come by. Anyway, that's the only purpose of that. So yeah, no, these batteries are both dead in a doornail, and hey, you just hook them up and they've come back to life. For a while they were weak, but what I was doing is, you know, you just leave them connected to the charger, and it's just a constant voltage, so it never overvolts. It just sits and it just soaks at that constant voltage, and it's helped a little bit. These batteries have recovered. Anyway, I'm rambling. These other batteries, the circuitry intentionally goes open circuit. Now, I suspect, I don't know, I actually see it glow a little bit there. That battery, well, if you'd focus, you fuck. Want to focus? Ish? Something? I don't know. Anyway, a lot of times chargers like this, and I guess, oh, that's scary. Yeah, so this is what I know for sure. This is the old nickel cadmium nickel metal hydride charger. It's not for lithium batteries. The old Milwaukee old style stuff. I have some of these. Man, that zoom is not right. So these, if the battery gets too low, it won't charge, but it's the charger. And I think you'll see the little LED will flick for a second and then it'll shut off. So these are pretty simple. You just hook them up to anything. You could have a 12-volt car battery. I have my lab bench power supply. You could use maybe a car charger, although these are a little bit brutal. They put out kind of a nasty waveform, but this doesn't really have any interesting circuitry in this. In fact, some of these might not even have cell balancing, because the nickel cadmium nickel metal hydride has enough of an internal discharge. They kind of self top balance, whereas the lithiums, you tend to need cell balancing done by a circuit board. Anyway, I don't think there's any circuitry in these old batteries that would be damaged by this charger. But bear in mind that this charger will destroy circuitry anyway. So yeah, these, you just hook them up to power and you just give them some power, forcefully charge them, and it doesn't need to be much. You know, this is 18 volt. You can hook it up to the 12 volt charger. Even though this 12 volts is too low, it's dumb. It's always spitting out power. Hence, you can charge this even though it's dead. There's no smart charger, you know, cutting you off because the battery's dead. Anyway, I would guess, and I don't know, I would guess that these Ryobi chargers, I don't have one in front of me, they don't have that ability. In other words, I would think, any Ryobi battery you shove in there, the charger will charge. So the way that Ryobi produces that kind of safety effect, and to prevent you from jump-starting the batteries and to make you buy more batteries, I'm sure, what they do is this battery, once the cells get to a low enough voltage, the circuit board just goes open circuit, and you're done. It disconnects you from those batteries. You are unable to use them. So I was trying various different methods to, hey, you could take it apart and solder it, but you know, these are the safety torque screws. It's not designed to be taken apart. Focus, you fuck. I have torque screwdrivers. I don't have any safety torques, so what I do on those focus. Anyway, you drill them out with a small drill bit, and you pop the head off, and then you can, once you've drilled them all, you can take the top cover of the battery off, and then you use a pair of pliers to grab what remains of the screw that's sticking out, and you can kind of unscrew the bits, and then you got to go find screws, and that's kind of it's a whole ordeal, and it's a pain in the ass. So what if, yes, I know, honey. What if we could jumpstart these batteries, or, well, not jumpstart, but trick these batteries into allowing us to charge them without taking them apart? That's what I'm hoping to do. So I actually did it successfully with this one. I started gentle, right? Obviously I don't want to damage these cells if I can avoid it. So I started with this battery charger, and I just hooked it up. These chargers, I have some lithium iron phosphate batteries in my solar system, and these chargers have damaged those batteries to the point that once they drop below a certain voltage, the circuit board can no longer take the battery offline because these chargers damage that circuit board. That's how sensitive these things are. Now, I think the issue, this didn't work because the batteries weren't connected. I think if the batteries were connected and current was flowing, the nasty, jagged waveform, unsmoothed, that would probably damage that component. I know. Oh, I know. Basically the barrier, the depletion area or whatever, is such that even though the power is dirty, it's not able to bridge that. So then I tried, this is a microwave oven transformer. You could probably use any number of things. I know. And so I used this in series, so I had, positive hooked up to the charger, and then the negative was hooked up to this, and then, the other, and I just went through that primary. So again, this is DC, so I'm just using this as a choke, basically. So this is hooked up, this is actually the positive, but this is kind of where the negative was hooked up, and then I had this wire, and so I touched this wire to there, and then I tried shorting the battery and disconnecting. What that does is that makes that little voltage spike. With this thing, current flows through my dead short. When I disconnect the short, think of this as an electrical flywheel, this kind of inductor, because again, we're not using it as a transformer, we're just using one winding. This inductor is an electrical flywheel, and so it's hard to stop a flywheel. It has a lot of inertia. So when I disconnect the short, this thing wants to keep spinning, basically, so you get a voltage spike. That wasn't enough. I was hoping to arc, through and get to the other side of it. What I did with this one is what you see here. So these are just two wires, just two blade connectors, and they go to an old vacuum cleaner cord, and I just plugged it into the wall really quickly. Oh wow, you see the black and the melted brass. Focus, you fuck. And so this is, that battery is actually charging now, and it appears to be working. Could you focus, please? That looks focused. Yeah, you see, so this melted brass actually wasn't there, and that black discoloration. This is actually just from that battery. Anyway, I was hoping the voltage was high enough to, and normally silicon fails in the short circuit position. So I hooked up something that's designed for 20 volts to 120 volts AC, and I cooked it, and now it's failed short circuit. So now this battery is being charged. Oops, I touched it. But you can actually see, you can't see. Through my crunchy zoom, yeah, you can see it appears to be charging okay. Winds. So this one's been charging for a while, and I'll show you the status of this one. I think it's no longer at the current limit, so the charger's up to 20 volts, and look at that, the current has dropped off pretty low. So yeah, this one is, it's not going to be full, but it's going to be like approaching full. Let's do some experiments and see how fucked this battery is. Okay, so this battery is at like 18.29 volts. Granted, it's not fully charged. So then, it is, by the way, it is warm. And I think I was noticing more heat in the middle rather than on the outer edges, like right there. So there's one particular cell in there that's getting warmer than the other cells. So, anyway, seemed like it was holding okay. This is a 12 ohm resistor, nice high wattage. God damn the focus on this cocksucker. Anyway, 12 12 ohm, 18 volt, that should be, what, 1.5 amps if you math that out. Anyway, I hooked this up to the voltmeter like this, and I dangled, you know, the resistor from the, and I was able to measure voltage as I pulled current. I ran it for about a minute, and this resistor is, it's actually getting warmer as it sits. All the heat was inside, and the heat is slowly conducting to the outside. But anyway, this entire resistor is getting quite toasty. So, and it's, yeah, it's at 18.18 volts now. So, it seems like a working battery to me. It may not work, you know, as well as it did originally, but heck. This one I measured the voltage, 18.47. So it seems like the voltage has actually come back up. After the load I put on this and I let it sit, it seems to have actually come up a little bit and recovered. So, interesting. So yeah, this one appears to be great.
Yeah, man. There it is. So this is super crazy dangerous. That right there is Balin Mania, and we are going to do something really stupid today. This is a terrible idea. Balin might die. It was making me uncomfortable. Go, Balin!
You riding this?
What the fuck is happening?
Balin said not to talk crap about this camera. It's a piece of shit.
This is so unbelievably sketchy. Why would you put me through this, you jerk?
That's the power of really old engineering.
It'd be nice if it didn't kill me. It's not required.
I felt that fucking pop.
Make a wish, everyone. Make a wish.
Not okay.
You went too far. This guy, man. This guy.
And it's not trying to, like the 120 volts AC, it's not running those batteries backwards. But we'll see. We'll see what we can do. You're a whiner. You're a whiner. You're a whiny boy. You're a whiny boy.